In this video, we continue on looking at the conduit looping method. As part of this series, we've already looked at all the wiring diagrams that helped us in the video before this in order that we can install our 1.5mm squared single insulated PVC conductors, and we wired from our consumer unit to our lighting point and a one-way switch. We inserted all those cables using that wiring diagram, and now we're at the stage where we need to do the second fix. In other words, we're going to install the light and the switch and make off those connections, and we're going to see that in this video. First of all, we're going to make off our straight skirted batten lamp holder. We looked at this in a video where I described the rig that I'd built here and suggested you might want to build one yourself. You don't necessarily have to use these, but these are the right ones for the conduit looping method. And we only have 3 terminals. We have one that could be either line or neutral, and the other one could either be line or neutral. Remember, this is a bayonet cap lamp holder with 2 pins in there that have no polarity, so it doesn't matter which one's line and which one's neutral. And then the one at the very back here is the circuit protective conductor connection. So we're going to make that off first. So in order to do so, we're going to need to unassemble it. So we take off the skirt and the ring supporting it to break it down, just so we can get our screwdriver in. So in a college setting, this is obviously where it all goes a little bit wild, because you've got to remember to rebuild it at the end of each session. Otherwise, you'll lose elements of it and won't be able to rebuild it. So there we go. So we've broke it down. So we've got just the connecting part. Now we can get our screwdriver in here in order to make those connections. In the previous video, we learned how to wire this circuit. If you haven't checked it out, I'll leave it in the eye above my head. But we've got our conductors here. Just a quick recap. We've got 2 circuit protective conductors. We've got our neutral and our switching line connection. There is no connection for loop, which we've looked at in previous videos where we use twin and CPC cables, sometimes on site called twin and earth. So we've just got to make off these connections into here. Now, for the first time in a long time, I probably won't be doubling them over. If you look at the size of these terminations, they are very small, and we're going to extend this circuit in future videos. So the chances are I'm going to have to put more conductors in some or maybe even all of the holes within here. So I'm going to single them over, and I might not even twist them up in future videos as well. So I might just strip them back and insert them, which is a bit different for me because I usually double everything over and I normally twist it up. So let's back off the screws. Again, let's not back them off too far because obviously they will fall out. They're quite small. So again, it doesn't matter which one this one is, whether it's line or neutral. Back that one off, and again, doesn't matter whether this one's line or neutral. Remember, that's a switching line conductor, not permanent. And then the one at the back, which is a little bit tricky to get to, is our CPC connection. Fully insulated, so it's just there in case we ever change it for an exposed conductive part. So it's all plastic, there's no metal parts to it. So it doesn't matter which one's line or neutral, and we've got our CPC at the back. Let's do that one first. Different ways in which we can strip the conductors. Remember, the conductors are 1.5mm squared and they are stranded for greater flexibility, which we mentioned in a previous video. If we look at this set of 5-in-1 pliers here, we can see we've got a 1/5 and a 2/5 cutting element to strip the conductors. So I could take one of those, insert it into the appropriate groove, which is the top one, squeeze down tightly and just pull away. And you can see how easy that is. Let's do the next one. In we go. We strip the conductors back, and you can see they're longer than I need them to be because I'm just going to twist these up. Take my pliers and I'm going to get on the ends, and I'm going to twist my conductors, my 2 CPCs, and I like them nice and tight. At the moment, I don't know how deep these terminals are. It's a brand new accessory to me. So let's just trim the end off and see how long that is. That should be way too long. Bring in our lighting point, and we're just going to drop our CPC into here. And you can see that's as far as it goes down. So we're probably almost twice as long as we need to be on that length, which is good because I like it to be solidly twisted. So let's twist the other ones before we trim them back to length. On the very ends of them, I'm going to twist them up. And once I've got them twisted nice and tight, normally students would give up too early. And we get them nice and tight all the way down before obviously I can trim that end back. We know they're too long, so I'm just going to cut them just about there. Both cases, and if you're unsure, just give the ends a little wind over again. So hopefully they'll go in nice and comfortably into our terminal. So we bring those in and we find the back one there, which is our circuit protective conductor. You can see the symbol for earth on there. Okay, so that's where our CPCs are going to be connected. Pop them into the accessory and then just see if we can get them to go in. Might be a little bit tricky first of all. So there's 2 gone in, they're not doubled over. That's quite a snug termination in order to get those to fit. I've pushed them all the way in. I'm going to screw into the copper and not the PVC. but you can see why if we had 3 that we might not be able to twist those up. We might have to leave them singled in without twisting them up. So we've got them twisted at the minute. So they're connected in there, and now we can look at bringing in our line, switching line and neutral. Doesn't matter which way around we go. So just check we're in there. Maybe could have gone in a fraction further. That's probably because of the size of the hole. Give them a tug. Yep, that's nice and tight. Just check it again. Yep, firm. Now we're on to our other 2. Doesn't matter which one we go next for. We've got to make sure we can get them in here. Well, in singles, with the job we're doing, we can actually just pull our conductors round a little bit, so we haven't got to worry too much about our length on these small jobs. So if you've got a little bit too long, you might want to find you just take a little bit back, either that or we could cut it. So just poke that one back down till we get our reasonable length. Okay, so how else can we strip it? You take a pair of side cutters. This takes quite a lot of practice to get it right. Pinch into the PVC and then just pull it away. Let's do that again. So just pinching, not too hard, not into the copper, and then we just pull away. So it's my thumb and my side cutters together to pull that away. Take my pliers. I'm not going to double these over because I know in the future I'm probably going to add to them, and we saw how tight the CPCs were to get in when there was 2, so we don't want to be double them over. Trim them back. So that's my neutral. Now this is my switching line connection. In this method, as we saw in our wiring diagrams, there is no loop-in terminal because we take the permanent line, which we'll see in a minute, directly to the switch. Trim those back and then bring in, and it's again, like I said, doesn't matter, it's not even labelled which ones they are. However, if this was an Edison screw, which we've talked about before on the channel, there would be polarity. In other words, they'd be identified as L and N. So here's my neutral, check for depth. So if we're there, probably a fraction shorter. I'm just going to take a little bit off that and then drop my neutral in, and like so, hold it down into position, and I'm going to tighten that one off. It's important you hold it. You notice my hand is on the top holding that neutral conductor in position so it doesn't work its way out as you screw down onto it. So get it nice and tight. Let's check the depth of this one. Maybe a fraction, just going to trim it a little bit. And then we go pop that into position, and then we can look at rebuilding this. So that's my switching line done as well. So again, I'm just holding it down in position with my hand just to make sure that it doesn't pop itself back out. So they're nice and firm. Let's give them a little tug. Yeah, we're happy with that. Now we can look at rebuilding it. So we've got to make sure we get this on the correct way around. So it's going to go on like so in position. Obviously you don't want it that way around. Followed by our ring to hold it in position. Once we've got those, obviously try not to cross thread it. Some students, when they put it on, they start getting it really stiff. That's wound on really easily because obviously I haven't cross threaded it. There we go, so wind that down. And then on goes the skirt. And then we can position this on top of our accessory. Right, now the problem is students now tend to think, well, I'll get this screwed down straight away so it looks like it's nice and finished. The problem is we're going to need to test it at some point, and testing it for us needs us to get to the back of it. So we're going to need to get to the CPC and the switching line here. So once we put it back on there, obviously that's going to be really difficult to do so. So are we going to be able to probe onto those 2 positions? No, we're not. So the trick is not to rebuild it at this stage and get all excited that you're finished, is to leave it ready for that testing process. So you now see you can get on with your probe onto the CPC and the switching line, which would have been incredibly difficult at that stage. That's the one thing my students always do. They always rebuild it and then find they can't get on them to test. Would be nice if we were testing from the end here, but we're not. We're still going to test from in here at college. So that's made off. Our straight skirted batten lamp holder almost ready for testing. We'll do our one gang one way switch next. Our switching position here, we've only got a one gang one way switch. There's only one position in which we're going to turn on the light in a fictitious office number 1. We did describe in one of our videos where we talked about a rig that maybe this could be metal clad. We certainly wouldn't be potentially mixing white boxes with black conduit, but we explained that in that one to keep the price down. And this is what we've got. We're going to use a switch that we've probably used when we're using our twin and CPC exercises early on at college. And it's one gang, so it's got one switch. And when I turn it over, we've got common and L1, so we've got a one-way switch. However, lots of colleges don't necessarily use one-way switches. They use one gang, and when you turn it over, we can see we've got common L1 and L2. So this is a two-way switch, which you can use as a one-way switch. It means you use common and either L1 or L2, and when you test it, you need to make sure you rotate your switch so it's round the correct way. So if you're finding it switches in the wrong position, you have to rotate it around during your testing process. So you could use a 1-gang 2-way, and lots of colleges do. At my college, we tend to use a 1-gang 1-way switch where we need a 1-gang 1-way switch. So common and L1. So which one of these is common and which one is L1? In our previous wiring video, we put a little nick into the switching line conductor, the one that goes back to the lamp, and that makes it our connection for L1. And we've left this one blank here, which is our connection for our common. Well, we could prove that if we wanted to, because it's such a small rig. By just doing that, we can see that I can move that conductor that comes in and go into common and comes from the consumer unit. It would be really difficult in obviously a large installation to do that, and if you hadn't labelled them up, you'd have to test those conductors. But we've got switching line with our nick in and our permanent line that goes into common. So permanent line into common, and L1 will take our switching line. So bringing our pliers again, we go into the groove, which is the 151, squeeze all the way down and strip it. Just going to snip that one off, and we're going to do this one as well. So this one being our switching line conductor. So I'm going to do my switching line first. I'm going to twist it up. I am going to double this one over. So take your time. Students tend to stop really early on with that twisting process and don't keep going. So you can see that's nice and tight. Trim it back, roll the end again. And then as always, take slightly less than half, fold it against the pliers. And we can see that we've doubled that one over. And we've got a nice doubled over termination, which is going to be our L1 connection. So bringing it in, back off our screw of our 1-way switch, and hopefully that will go in. Remember, this is 1.5, it's going to be tight. Ah, look at that, it doesn't go in. Okay, and that's the issue. Over the years, what's happened is these get smaller and smaller and smaller. So I'll just back it off a little bit more. We'll see if it goes in. It doesn't. So it does depend on the maker switches that you've got and the size of the brass terminals within them to see if they can allow doubled over terminations. Remember, we've stepped up from 1 mil when we're using our twin and CPC cables or twin and earths over to 1.5, and by twisting it and doubling it, it doesn't go in, and that's going to cause us some issues later on as we extend the rig. And that's when I said we might find that we don't twist them together. Easily solved. All we need to do is obviously snip off the end. Check we're happy with that end as well by just giving it another twist, and you'll find now you'll comfortably go into that terminal. So over the years, and I've been teaching for 18 years, these holes get smaller and smaller and smaller, and we're finding that we can't always double over depending on the manufacturer. So there we go. So that's going to be a singled over termination into there. I'm going to tighten that one off. That's going to be our switching line connection. Again, you notice my hand is on top of it, holding it in position. So that's holding the conductor down as I screw into it. And now we can do our permanent line, which will go into common. We now know with this maker switch that we can't double it over. So we're twisting it up. You notice none of the strands are coming off. So none of these are breaking away. If they do break away, you've got to start again, snip it back and start again, because we don't want the conductor to be a smaller cross-sectional area at the point of termination. And then just give it another roll through. And this will be our common connection. We'll take that one back as well. And drop that one in. So that's common connected as well. CPCs are there, but of course we've got a fully insulated system. So our CPC is really just going to be left floating around in the back of the box. Would be nice if there was a terminal in the back of the box, but these are socket boxes effectively, and there is no terminal. If you've got a metal clad one and there's a CPC connection in the back, that's where you'd connect it. And some colleges also make a temporary connection in the back here. I'm going to use these Wago connectors. So I'll open these up. I'm going to use these Wago 221 connectors, and these are 2 conductor connectors. And again, on the side of it, it does say the amount of insulation that we need to remove being 11 mil. So we need to remove 11 mil of that. And as they're a class 2 conductor, in order to insert them, I am going to have to lift up the levers as well. So bring it back over from a CPC, and I want approximately 11 mil stripped. Take that one back. I can just check on the side, and I'm a fraction long there, so I need to trim it back. I'm just going to take a little bit off those. And why is this so handy is that I can actually have another one. So to test these is great. There is test points on the Wago 221, but they require a special probe that you've probably not got at college. So what I'm going to do is I'm going to take another piece of my circuit protective conductor cable, and I'm going to strip that back. So I can then have this as a test lead. So I just need to check my length. Is that approximately 11 mil? Would you say it's a little bit long? So a little bit long. Just trim that one back and insert it. Close down my levers, and if I strip this one end, I can use that for a point at which I can test to. So I can prove my circuit protective conductor gets down to here by testing on here. Even though the Wago 221 has test points, they can be tricky in college to get onto. So then I'm going to leave that in the back of the box there, purely for testing purposes. Once I've tested, I can just remove that link out of the way. So we know it's fully insulated. Okay, so we've got a fully insulated switch, box and conduit. So the CPC is just there in case we ever turn it into an exposed conductive part by adding a metallic switch onto here. We know that would be an exposed conductive part and require connecting to my circuit protective conductor. So that's my switch made off. It's a one gang, one way switch controlling the lighting point, say in office number 1. So to complete the second fix, all we've got to do is make the connections within the consumer unit. And we've said in the previous video that the reason we didn't like this one too much, the RCCB here is an AC type, and we're trying to move away from them. This is a college setting, and often it's rare to have an RCD, even though some circuits require it. And remember, we did say that this lighting circuit didn't. It isn't a domestic dwelling, but the RCD protection by the RCCB happened to be here because we're using this garage consumer unit from Fusebox. So I'm going to dress these singles in, and it's quite tricky to make them look nice and neat compared to when we did twin and CPC or twin and earth cables. But I'm going to start off by positioning my neutral. I'm going to be using fuseway number 2. And this is fuseway number 1, so we're going to be using the B6 amp MCB here. So I'm going to need to use position number 2 in both my neutral bar and my earth bar at number 2. So remember, this is the main switch as well as the RCD protection. This is circuit number 1, rated at 16 amps, and circuit number 2 is rated at 6 amps for this lighting circuit. So I'm going to dress these round at the top, just leave a little bit extra on them. It is tricky to make them look super neat, so I'm just going to curl those out the way. And we're going to strip it, and we're going to double this one over. Perhaps I'll take my side cutters this time. So side cutters and just push away as we go. So you just push it away, and then we're going to twist those up as we've done throughout the video to make them nice and tight. And then we will double these over and insert them into position number 2 in both the neutral and earth connections. That's the earth bar where the CPC will go. So take those, trim it back, twist again, and then we're going to double that one over. Let's make the connection nice and neat, and we're going to position that in number 2. I'll take my posi drive screwdriver to start with. Just going to back off the screw. I'm just going to gently put it into position. So we're in, and then just gently wind it down. I'm not going to tighten it off just yet, and I've left the neutral connection there. I'll do a similar thing with the CPC. So going to wrap that round at the top and then just bring it back into position and go into number 2. So I probably won't have to lose much off that one. Take my pliers this time and then just push away. And we'll go and tighten those conductors up. Remember, we don't want any of them to break off. If they break off, you've got to start again. Got that one, trim it back, twist off the end, slightly less than half. We'll defold it against the pliers, and then we've got our doubled over termination. I can pop that into number 2. Again, take my posi drive screwdriver, just back off the screw, and drop it into position, and then we'll tighten them up in a minute. Once we've got all the connections made, we'll tighten them up using a torque screwdriver. So just pop that one in there, number 2, so that's connected. And again, you can see it is considerably difficult. Number of things, I'm doing it upside down, which obviously makes it a little bit harder for me, as well as the fact they are single cables, so just keep those out of the way. And then we've got our line connection. Can't even pass it behind here, so we can't get behind the breakers. So again, to leave it a little bit longer, I'm just going to position it. What should we do with this one? Let's go, maybe if I just hook it right there. I'm just going to bring it back round like that. Okay, so I've just had a quick look myself, so I'll come round, so I'm going to do that one, and we'll make that connection into the top of the 6 amp type B MCB. Twist those ones up. Again, I've never used this style of consumer unit before. Marcus gave me it, which was good of him. I may change it out for a different one as well, so I'm not overly comfortable with it. So fold that one over, so we're nicely doubled over. As we're going into a cage terminal, the top of this breaker, I'm going to try and lay it flat. So I've laid it flat, so I've not gone side on, I've laid it flat in order to go into that cage terminal. And once I'm in there, I can tighten that one down, making sure I'm going into the copper and not the PVC. Again, I'm not tightening it up, I'm just tightening it down. So there you go, just that's it, it's not tight. So let's make that look a little bit neater. We'll have a play around with these at some point. So there we go. So that's the conductors in. Not overly impressed with them just from the point of view they're singles. I've had to keep them up the top. So we've gone number 2 for neutral, number 2 for our CPC, and we've used breaker number 2 as well. I've done it upside down. I will make a separate video on how to build this board up, how to put the DIN rail and the breakers together, so clip these onto the DIN rail as well as put the bus bar in as well in a separate little video. But there's our connections made reasonable but not brilliant, but again I did it upside down. Now let's think about returning these to the required torque settings. Bringing the manufacturer's instructions. The torque settings are here for both the RCD, which is this section here, which we're not connecting to, the MCB, which we're doing the number 6. The MCB goes up to 16 millimeter squared cables. We've only got 1.5, and it's 2.5 Newton meters of torque. And the earth and neutral bars are identical at 2 Newton meters of torque. So start off by doing the 2.5 on the MCB. And we've got a torque screwdriver currently set to 2.4 Newton meters of torque, so we're going to need to adjust that to 2.5. Pull out the section that holds together for our screwdriver, bring in our bar to adjust our torque setting, and then we've got to work out which way to wind it. So if we go this way, I've got no number there, and then we come to there, we can see that we've got 2.6, so we're between the two. So I need to roll back, not all the way back to 2.4. I need to go in the blank window in between, which means we set that to 2.5 Newton meters of torque with the bar. Bring back in our screwdriver holder and the tip. And the tip now is a slotted posi, so it's slightly different than what we're perhaps used to when doing screws for electrical accessories to hold them in position. We've got a slotted posi now. And we lock it into position, and we're ready now to use that against the breaker. So I've gone to the top of the breaker, and I will be tightening this down. I only did it loosely to start with, so I'm going to turn it. You see the screwdriver's moving. We've got no clicking sound at the minute, so we're waiting for that click. One more, and let's see if we can get it. That wasn't the click, so press a little bit harder. There we go, we heard that click. So lots of pressure on top of the screwdriver. We only need to hear it click once. That's got it to the required torque setting of the MCB here at 2.5 Newton meters of torque. We need to change it for the earth and neutral bars. So we're going to change it over to 2 Newton meters of torque. So back through the process again, pull out that. We're looking at the window. We're looking to loosen it off now. So that's our 2.4. That should be 2.2. That would be 2.1. So if we go to there, we've got our 2 Newton meters of torque there. So back in, we can reassemble. And we're ready now for both the earth and neutral bars. I need to lock that in position. So as you watch here, there's a little lock-in section. So pull that up, and that locks that into position. It just came loose. So there we go. So we lock that in. That's held into position. Drop it on top of our screw. Plenty of pressure down. So we're going to see it turning because we only did it loosely. And then we should hear one click. There we go. That's clicked and got to the required torque setting. We move across now to the earth bar where our CPC is connected. And again, one twist, we're getting tighter. One click is all we need to hear. There we go. And we've got that to the required torque setting. So that's it. That's connected then. So we've got 6 amp circuit breaker for our lighting circuit at 2.5 Newton meters of torque, which is also displayed on the breaker. And we've got the 2 Newton meters of torque for our neutral and earth bar connected. Never happy with the layout of the conductors. I'll probably do a separate video on laying these out slightly different where I can stand the correct way round. But that's all connected now. So I've shown you every single termination of this one-way lighting circuit using the conduit looping method. We connected our consumer unit, our lighting point and our one-gang one-way switch, and we had to make some decisions, didn't we? We twisted all our conductors up, but in this series we may not continue to do that because of the size of the holes in which we were terminating into. Sometimes we doubled them over and they weren't big enough to go in there and we had to reverse it back to a singled over connection. At this stage you're probably going to find maybe in a workshop you're packing away, it might be a case at that stage you have to rebuild your light fitting and unassemble it, which we're going to need in the next video where we carry out the continuity of CPC and include the polarity test, and we follow it off with the insulation resistance test. If you're working your way through this series of videos or you've just jumped into this one, remember the full playlist will be linked in the description below if you want to check those out. I will also do an individual video on how to dress and connect the conductors within this style of consumer unit, as well as inserting the MCBs in order to make a nicer layout maybe than we've done in this video. Obviously I did it upside down as well. But as always, I hope this video has been some help.